Hi guys, welcome. Thanks for joining me today afternoon for the presentation on next generation serverless fabric for containers. Bit of agenda for today. What we're going to be talking about is how infrastructure as well as application ecosystem is changing and evolving, and how it has evolved since the last 4 or 5 years. We're also going to be talking about the challenges people are facing as the enterprises are transforming digitally into this new ecosystem. We will get into how Avi is solving the problems that are being faced as a part of this digital transformation. And if you have some time, I would also like to do a live demonstration showcasing how this platform is helping DevOps to manage these complex platform and application problems in an easy, elegant, and in a very smart way. So, just to introduce Avi for those of you who are not that familiar with us, we are a 4-year-old company in software-defined smart load balancing, security, and application services with global presence. We have a global footprint with strategic partnership with Cisco. We're backed by top Silicon Valley investors. We also have global 2,000 high-end customers, ranging from tech companies, media companies, as well as financial sector around the world. Now, coming back to the topic, if you see what's happening in the infrastructure these days, the way infrastructure has evolved in the last few years, is what we're seeing is that compute is becoming web scale. And what I mean by that is that we do not need workload-specific hardware nowadays. I mean, gone are the days when you would have hardware which was specific to a particular workload, for example, storage. You had a different hardware for networking, you would have a different hardware. Now everything runs on the commodity x86 servers. The whole data centers are made up of those servers. The complexity of the workloads has actually moved above. We had a couple of talks today which talked about hard convergence and other features. There was a talk from the Oracle folks, Romello, which actually mentioned the same thing. The complexity has moved above the stack to virtualization. The virtualization, the VMs, containers, all these guys have taken the complexity from the hardware to a stack above. So what initially used to take a few months for a data center operator to set up a data center now takes a few hours. For example, if I want to change few racks of my data center into just web apps, I can do that in 10 minutes. And so it's true if I want to change it to a different kind of application workload. So with that kind of flexibility, we can see that compute is actually becoming web scale. But is that true with all the other network elements, like load balancers or any other network services? That is not what is happening in the network side of it. If you still look at the load balancers, for that matter, the legacy load balancers, they're still proprietary appliances or hardware. You cannot scale them as compute is getting scaled these days. You still need to manage each of those devices separately. You still don't have those centralized management. Automation is still lacking. So what we see is that there is still a gap for network services to reach to a level where compute has already reached. Same is happening on an application evolution side. An application which used to be a monolithic application with each of the functions being a part of that monolithic application has changed nowadays to a microservice architecture, which means that each of those functions that this monolithic application had have become individual services in themselves. And there are definitely reasons why that's happening, right? Because compute has become web scale. You need to start utilizing that web scale performance. So what's happening is each of these functional modules have become services in themselves, which can be deployed individually, can be built individually, and can be scaled individually. That's great, and that's exactly what a developer always dreamt of, right? Now I'm not dependent as a developer on any other dependency of some other module in my application. I can scale on my own. I can upgrade my application or my service on my own, which is great, right? this completely goes in line with how infrastructure has moved, how deployment of the infrastructure has moved. But if you look at day 2 of it, as I was talking in the panel discussion, day 1 seems pretty good, right? Developers are happy. They can actually do faster deployments of their applications. They can scale independently. But for all this to work in the production environment, there are still a lot of challenges. And I'm going to be talking about some of those challenges which I have faced. Prior to Avi, I was an architect, and I built, I would say, one of the biggest container cloud in the world, which was running on-premise. We face same problems. When I talk to other customers, when I talk to other people, folks like you, they're facing the same problems where they're running this hyper-converged, highly scalable architecture. One of them is service discovery. And what I mean by service discovery is the fact that now these services are microservices running all over the data centers. The application, which used to be one monolithic application, is now hundreds of services. So you can just imagine the complexity and the dynamism of these services. They move, if they're containers, they move from one node to another, and they're very dynamic in nature. So it's not easy to have a static IP address to them. The IP address is not static anymore. So you need to start discovering these services. With discovery, you have many problems. There are many ways you can discover them. You can do load balancing, you can do DNS-based discovery, and IPAM. Now, all of this is needed if you need to start running and operating this microservice-based infrastructure and application. Centralized visibility and monitoring. Now, what's happening is with the dynamism of these services and the amount of services that are running in scale around the data center, you have a lot of communication going on between a service to another service. Now, for an operator who is managing this infrastructure, for the operator to figure out what's really happening, there is a lot of insight that is needed to see what is going on between these two services, what is happening as these two services are communicating. Not only that, the fact that these services are running on a shared infrastructure, it's not that easy. It was actually one of the biggest problems that we face. It's not easy to pinpoint where the problem lies. The problem could be with the shared infrastructure. The problem could be with the application itself. So it's become really, really important to get the visibility to what is happening within the data center. Deployment upgrades, or we can also call it automation. The primary reason, as I said, why developers are loving it, why everybody is actually transforming their application architecture to a microservice architecture, is that it helps them do faster deployments. Right? You can build your containers, you can push the containers, you can run the containers within seconds, and exactly that's what Facebook does or Amazon does for that matter, right? But with that, there are a few more requirements now what people are asking for. What they're saying is, you know what, it's easy to deploy, but it's also easy to break things when you upgrade from one version to another. Help us do canary deployments. Help us do A/B rollouts. And when I mean by A/B rollouts, I mean real A/B rollouts, in which a version 2 of an application, if I, for example, am running a version 1 and I suddenly want to deploy version 2, I've tested it in my test setup. But I still want to test it in the actual production. I still want to deploy it in the production, and somehow magically transfer some of the traffic to this application, the newer version, let's say 5% of the traffic, and see how it behaves. If it's behaving well, maybe put some more traffic onto it. And if it's behaving great, completely shift over to version 2. This is the kind of capability people are asking for. And the last is security. This was the major concern, is the major concern still when we are talking about microservice-based architecture. And the main reason for that is all these services are sharing the same platform. So if I'm a tenant running the service on the same platform as you are, there's of course a question that how can I be sure that you are not going to do something to my service? How do you secure the things? And that's where the term like multi-tenancy has come into picture. It becomes a little bit tougher in a container-based environment, as I said, because you're sharing the same infrastructure. which is not true with VMs or bare metals because they're isolated in itself and it's easy to do multi-tenancy. But how do people do that in the nature of the microservices architecture? Also, I'm sure you guys would agree with me, perimeter-based security is no more a concern now. I mean, it is a concern, but it's already been sorted out. If you look at the recent attacks that are happening, the security, the attacks have actually happened up the stack of the application itself. So they've actually gone through the perimeter. They've hit the application at the HTTP level or the application level itself. With the current firewalling, as I showed you in the beginning, the way load balancers are still appliance-based, it's really tough to have an application-based firewall configured for each of these applications, which are so dynamic in nature. You don't want to spend days and weeks configuring firewalls specifically for each application, right? So you want something which can be dynamically attached to these applications within minutes or within seconds, right? Create the rules which are pre-populated and secure these applications. So if you look at what we just talked about, all these big challenges that infrastructure guys are facing or the applications that are facing as they're digitally transforming, it all falls into a full stack problem kind of a thing, right? Starting from the fact that you need an enterprise class load balancing, you need source discovery, which means that you need an integrated IP risk management, you need integrated DNS, to visibility and monitoring, and to firewall and security. So what are people doing about it? So if you ask, and I'm sure most of you are doing the same thing, what people are doing is for each of these problems, people are going to the software solutions. But what the software solutions are doing, so if you just look at it, what I've done is I've created a mapping of each of these challenges to the software solutions which people are mainly using to solve this, right? For load balancing, people are going to, if they're on Amazon, they're using Amazon ELB. If they're on-premise, they're using Proxy or Nginx. Same is true with source discovery. They're using open source softwares like Consul, SkyDNS. For visibility, Prometheus, Sysdig for that matter. For firewall, policy management, security, there are new technologies like Istio, which does policy management as a part of service mesh. There's Cilium. For IPS, there's Suricata and whatnot, right? I mean, the list goes on and on. For visibility, there's Grafana, Elk, and whatnot, right? Now you can imagine what happens on the day two when an operator is supposed to be managing this infrastructure. This is a problem I faced prior to Avi. When I said when we built this big data center, it was cool day one. It was a chaos day two. When we tried to solve all these challenges by getting all these software solutions out there, it's whatever was a dream come true for developers actually started becoming a nightmare for all the DevOps folks, right? So what Avi is doing here in this space is, the fact that Avi is sitting at a very strategic location, being the load balancers, and with an architecture that Avi is a microservices kind of distributed, scalable architecture. If you're sitting strategically at a place where all the traffic can go through us, and our proxy is sitting on all the nodes, is it possible to get all these challenges, all these features pushed down to an infrastructure platform and have a single pane of managing these problems? The answer is yes, it is. And that is what Avi's service fabric for container does. Not only does it push all of these challenges and handle all of these challenges as a part of a single platform, which we call the service fabric, it also, if you look at the top one out there, it also integrates with almost all of the providers of cloud, whether it's public clouds like Amazon, Azure, Google, whether it's on-premise clouds like OpenShift, OpenStack, Kubernetes, Mesos, or even Docker Swarm. We integrate with all of those vendors to do automated stuff like, for example, auto scaling in those clouds. We had a presentation today where we were talking about spinning up VMs. What we do, we can do that. We can spin up VMs, or we can spin up EC2 instances depending on or based on the metrics that we get from our agents. And the reason, as I told you, the reason Avi could do this is is their architecture. If you think about the old days of how a load balancer application would look like, it would be a monolithic appliance with both management plane and data plane in the same appliance. Now, to scale this appliance, you would have to scale both management and data plane because you have to scale the appliance together, right? What Avi did was it broke down management and data into two separate planes. So you have a control plane and a data plane that's separate. The control plane is managed by the brain, which is called the controllers, and of course they're highly available. They run as masters, and the data plane is handled by what we call as service agents. But you can think of them as load balancers or proxies. And we can run them on bare metal. We can run this platform on virtualized environments like VMs or containers, right? For the sake of this talk, since we are talking about container-based service mesh, we are going to talk about the container clouds like Kubernetes and OpenShift. So by providing this complete stack solution, what Avi is doing is it's actually making it simple to manage microservices cloud. The service fabric in itself is a concept that is working because of the architecture that Avi already has. And the reason for that is, for this to work, we need to have these proxies sitting on all the nodes so they can get the data from whether it's the traffic going through them or it's the metrics that is being collected from all the nodes to make it work. This gives us visibility into the network traffic that's flowing between these services. This also gives us metrics that we can collect and perform actions on. I will show you in the demo, we can actually do automated actions on these metrics. And the reason we can do that is the fact that we are actually tied to almost all the cloud providers, whether it's Kubernetes or whether it's Amazon in the public cloud. We can automatically scale things up. We can automatically talk to their APIs and do whatever is needed. In terms of performance, I know there have been questions asked that when you're making a software solution like this, is there an effect in performance? The answer is no. What we believe is it's a myth created by hardware vendors that you need to run things on the appliance to get the best of the appliance. True in some sense, but not as big as an impact as somebody just said prior to my talk. What's more important is how can you scale up if the need arises for you to have more performance. And that is what the elasticity of Avi's architecture can give you, right? And if I need more load balancers, for me, it's just a single click to scale them up and increase the performance elasticity. With this, let's go into the demo for the service fabric or service mesh. But before I want to go into the demo, I would like to clarify why I put mesh in here. We started this project, like maybe a year and a half back, when we figured out that we can actually do this. We can push all these problems into one platform and solve this. What is interesting is, looks like the whole industry in the container native space also thought the same. And they created a concept called service mesh. So what we are talking today as service fabric of Avi is nothing or pretty much equivalent to what industry calls a service mesh. They do the same, service mesh does the same thing, it solves the same problem. We do it similarly and much more because we have more insights into what is happening in the cluster. So let's go into the demo. All right. So for the purpose of this demo, what I'm doing is I'm starting afresh. There is nothing running on these clusters. I have a Kubernetes cluster running here. Let me refresh this. So this is a simple Kubernetes cluster with some nodes here. There are 3 nodes in this Kubernetes cluster. There's no deployment in this cluster. And we have an Avi thing, and there's nothing running in the Avi cluster. What I'm going to showcase to you to start with is how easy is it to deploy Avi's platform onto, let's say, in this case, a Kubernetes cluster. If you look at the infrastructure, we can actually configure clouds. Right now there is no cloud running, that's why there's a default cloud, there is no type. But if I just, since everything is 100% RESTful API, if I just click set Kubernetes cloud, you will see that it will get configured. And you saw that, and there it is. So what happened internally is, let's look at what really got configured. The only thing that we needed to give Avi was access to the kube masters here, which is the master node IP. In case of OpenShift, it would be the IP of the OpenShift. In case of AWS, it would be the credentials to the AWS. That's the only thing I needed to give Avi. What Avi did was, it started talking to the kube master, figured out all the nodes that are running in this cluster, automatically provision the service engines on each of these nodes. So everything happened with just one click. Avi, as I said, the fact that we actually enable service discovery in these environments has an integrated IPAM and the DNS solution. So as a part of this cloud, you could also configure what is my IP address for the north-south service, what is my IP address for the east-west service, right? Of course, for the north-south, you will give a public IP address range. For the east-west, you can give a private IP address range, right? So that's about it. So once you give this, your platform gets configured on your cloud. And you can see that here. So if you look at service engines, you'll see all the service engines have gotten configured in each of these nodes. There you go. They're all up and running. Simple, point and click. User doesn't need to really know about anything, just needs to do very simple configuration to get started. Now, once we have this fabric already established on these nodes, now you can see the power of the whole platform, what it can do. So let me showcase what really happens. So we have the platform running. Let's start off an application on this platform. Let's do this. Let's configure a DNS virtual service. The reason we configure this is to showcase that we have an inbuilt DNS, which can help you do service discovery by just the domain names. And let's start some applications. They're nothing but normal Kubernetes containers, right? Just normal Kubernetes deployments that are going to be running. Let's go back and see what happened. If we go to Kubernetes cluster and we go to deployments, see from here, you can see that now. So we just launched a big application, which is comprised of many services. One of the services is App Photo. App Photo is a service which is a front-end service. That's why I'm putting a little bit more onto that. So that's the only service which is basically connected to the public interface. The rest of the services are actually the backend services, which are actually doing application logic, business logic, and whatnot, right? So this is the mesh, and each of them, you can see there are many pods, right? So each of them has multiple instances. So this makes my complete application comprised of these services. But in real scenario, it's going to be hundreds of these services, hundreds of instances of these services, and that's the challenges we were talking about that we would start facing. So let's see what Avi did with this. Let's go to our applications and see the dashboards. And what you can see is the Avi's platform automatically figured out that somebody started a deployment as a service in Kubernetes. It created virtual service for each of those services automatically. It automatically, based on the fact whether they are public-facing services or internal services, started giving IP addresses to them and DNS entries to them. There is another way you can look at them by just clicking virtual services, and you can see all of them have been given IP addresses by Avi. So this is not something which has been given by a kube IPAM or a kube DNS. This is Avi's DNS giving them the FQDNs and the IP addresses. And we can actually see whether the service is running. Let's click this. And you see it says hello Avi. So the photo application is already up and running. Now let's go back and show you the power of what really can we do with this. Let's look at multiple views that we have here. If you look at one of the views, you can see the services as a tree, where I can click and see which is the backend pool that is behind the service, what are the servers that are running behind the service. We can also see an application map. Now, let's start some traffic for application map to be visible. As I said, right, I mean, there are going to be these hundreds of services. The visibility to these services is almost unknown for the data center, was unknown. With our application map, if we start traffic, you can actually see what is happening in our cluster. Which service is talking to which service. Let's give it some time to come up. Let's go to our photo application. There it goes. Let's go to the photo application because that's the incoming thing, and there you see it. So what we've done is we've dynamically created an application map. Here now a user, an operator, can easily see that the photo application is the front-end application which a user is connecting to. In this case, the user is me because we just hit that URI. And the photo application is internally talking to inventory, is talking to checklist and shopping cart. You can click each of them and see who they are internally talking to or communicating to, which is great in terms of just pure visibility from a very high level. The size of the circle here is a gain of significance. It actually tells you the number of instances that are running for these applications. The bigger the size of the circle, the more the number of instances are running of this particular service. If we want to go to it, so this is a high-level view of what is going on, who is talking to who in your cluster. If you want to go deeper into each of these services, you can click each of them. For example, let's click catalog service here and see what is happening. As soon as we click the catalog service, you can see catalog service is talking to 3 other services, where marketing and inventory is talking to catalog, and catalog is talking to another service called sales. You can also get real-time metrics on things like what is the throughput between these 2 services on the edges of this. You can change this from throughput to anything else. If you want to see, say, the requests that are going in, you can do that. There is the same analytics on the site itself. Now you could just see how easy it is for an operations guy to get a deep insight into what is happening in this cluster. Not only the fact who is talking to who, but also the performance indicators on what is throughput going on between these services, what are the number of connections that are being sent between these, or the completed amount of requests. And this happens dynamically. As soon as I will delete something, things are going to change. Let's go back to our photo application here. Actually, since we just started traffic, it's actually better that I go to a different control cluster to show a different service here. This cluster has been running traffic since many days, so we will have a better view of what all we can do as a part for our engine. If you look at, so what I've done here is just clicked one service. It could be the photo service that we were talking about. If you just look at the graph on the top, if you look at what we're showing here, is how this application or the service has been behaving in the recent time. In this case, we're talking about displaying past 1 day, but that can be changed to an hours or month, and the current values could be changed to average or whatnot. But what's important to notice is we're showing what is happening with this application in whatever time we configured, in terms of how much time did it take for the client on an average to read the load balancer, which in this case is 101 milliseconds, from the load balancer to the server, from the server to the app leg, what is the response time from each of them. So you're getting all these kind of metrics on a single dashboard. The same metrics are being plotted here. This is really important. I still remember one for customers, and most of customers loving this view of the metrics, because most of the times when the applications don't behave well, people always say, you know what, it's the network that's a problem. It's not the application. The application was all fine. There's something went wrong with the network. But if we look at this graph and we look at the metrics, we can easily pinpoint that, for example, in this case, it was the latency here for the data transfer that was a problem, and was not the network. Or in this case, it was the response time from the app that increased between this time, and not the network. So you can clearly identify the root cause of the problem. So this gives you a very high-level analytics. But if you want to go deeper into kind of a needle in a haystack kind of a problem to figure out what is happening, we can see the logs of this service. You can actually see and trace every packet that actually went through this service. If you look at how intuitive this is, what we are seeing is all these GET requests that were made. We can click each of these requests and you'll get more details and data about what this request comprised of. You can see on the client side, if you see what was the client IP, which initiated this request, you can have a look at what was the browser the client was using, the device, in this case it was an iPad, the client was using, what is the certificate type the client was using. Then you can go into the load balancer, at the load balancer and figure out which is the load balancer that was servicing this request, what is the backend server that it went to, what is the URI that was called for. So you have almost all the information for each of the requests that are passing through this service. You can actually even view all the headers if you want to. On this side, there is more analytics. Like for client analytics, you can see, as I told you, you can see the client OSs that normally have been talking and requesting this service. You can see the devices, the top devices that are basically talking to these servers. Like how many of them are computers, iPads, and iPhones, whatnot, right? So this is what makes it really easy for an operation folks to understand not only debugging the problems in their application, but also who is using the application. What are the stats of the kind of people that are using? Can we improve on things if there are more of iPad or iPhone users that are using? Are we seeing any delays for some devices for that matter, or for some IP addresses for that matter? What we also do is, let's go back to our photo app, and since that is where our app was. What we also do is we give a health score to each of these applications. If you look at, in this case, an Avi demo application, the health score is not that great. It's 40. And that is not because it's not working. It's performing well, it's up and running, but we've divided health score not only based on performance and the fact that it's running, but also based on, we've given them some penalties. If in case it's using a lot of resources on the data center, and it's getting closer to using a lot of resources, we subtract the score. In this case, it's coming very close to utilizing a lot of resources, so there's a health score that has been subtracted. There's a security penalty. The reason there is a security penalty of -20 in this case is because it's using a self-signed certificate. So the health score shows you, even though your application is fine, it gives you feedback on what you can do to improve. In this case, you can improve your security, so your security penalty is not much. So that is more or less into the kind of visibility that we get from this platform. Now let's try to see what happens if I walk into my office as an operator and suddenly there is a security audit. And what the security says is, you know what, looks like some of your applications don't seem to be behaving well. There is an attack, looks like from your application A to application B, or we are seeing some anomalous traffic going on here from application A to application B. Is there something you can do to micro-segment your application? The answer is yes. So let's go back to our dashboard and look at the map, and I'll show you how easy is it to secure your applications. Let's, for example, click catalog again, and let's assume, for the sake of this demo, that inventory was an application that you don't want to be talking to catalog for the fact that inventory was not behaving well, or we figured out there's something wrong with inventory. What we can do is just click Secure VS, and automatically, first of all, we figure out what are the applications that we're talking to this service, or what are the services that we're talking to the service. In this case, is inventory and marketing, and we blacklist inventory. We just click it and blacklist it and save it. And you just saw that blue circle around this, which actually means that this application is a secure application now. We've just secured it, and you also saw that the arrow became red. We've secured it from inventory. Now inventory cannot talk to catalog. So we have secured the application. So this is the power of, and the ease and the intuitiveness of this platform on even doing complex things like microsegmentation. With this, I'll end my demo, and I'll go back to the presentation. So what we saw is how this platform enabled us to solve each of these challenges, whether it was load balancing, where we saw a front-end load balancing, we could do a north-south load balancing, had an enterprise-grade L4 to L7 load balancer, how we did an east-west load balancing, how we did service discovery using both for IPAM and DNS, and let's go faster since we saw this, and how we looked at a view of the system from higher up to needle in the haystack kind of a view, and how it helped us observe, triage, and secure faster. We looked at all of this. We also looked at how we can do microsegmentation, how we can help secure these applications by just clicking the application and blacklisting and whitelisting the applications we don't want to talk to. There are a few other features that I would have wanted to show, but for the lack of time, we'll just quickly browse through what other things that we can perform. One of that is blue-green upgrades. What can happen is you can create a version 2 of the application, and as soon as you create a version 2 of the application, the service automatically gets added to the main application, and now you can split traffic depending on how much you want to send traffic to. You can put 10% of the traffic to the new application. Yeah.
So some of the things that happen in app rollouts or service rollouts is you roll it out and you find that 80% are working fine, 80% of the consumers of that app are working fine, and 20% are not, are breaking and need the old version. Would this be able to handle that?
Yeah. This would be. That's exactly. And I would, maybe just after the slide, I can give you a demo, and this is exactly what this is for. So not only this, it will also be able to handle if the 20% of those 80% are not behaving well, why they are not behaving well, and automatically fix those things if possible. We can do that too. We did also do auto scaling of applications. So since we are taking metrics from everybody from all the applications, we can actually, based on those metrics, auto scale the applications. We run on hybrid clouds as a GSLB, as a global software load balancer. We can actually do cloud bursting. So for example, you're running on a private cloud and your capacity is increased in the private cloud, you want to shift to the public cloud, it can automatically happen. So we've actually seen how Avi Service Mesh or Service Fabric, with all the services pushed into this platform, is helping all the enterprises to deploy, to run, to manage, and automate their cloud application in a smarter way. Thanks a lot, guys. That's all I have.